Hello students, welcome to class 11 physics. In this video we are going to start our new chapter number 7, system of particles and rotational motion. And the topic that we are going to discuss in this video are translational motion and rotational motion. But before starting that, let us see what a rigid body is. So what is rigid body and explain rigid body. This term is new for you because till now we have studied about the solid body, right? Solid is something that will be having the closely packed atoms, right? And here the distance between all pairs of particles of system do not change, then this body is known as rigid body. This is the main difference between the rigid body and solid body. In the solid body, we can deform it, we can change its shape by some ways, let us say on hammering the metal you can deform that metal, you can change the shape of the can, right? So that body is called as solid body because its shape can be changed, whereas rigid body is such body which cannot be deformed. So we can say rigid body is a special case of system of particles. A rigid body is an ideal concept while solid body is a real one. Rigid body is a body with perfectly definite and unchanging shape. That is main difference between solid and rigid body that I have already discussed. That the solid body is one which can be deformed, which can change its shape, and the rigid body is such type of body which cannot change its shape. It has the particular definite shape. A solid body can be deformed while a rigid body cannot. For many particle purposes, a solid body can be treated as a rigid body. For example, wheel, tops, steel beams, molecules in planets. These are the examples of the bodies. That is, for a body, it can be ignored that they warp, bend or vibrate and treat them as rigid. So, student, you may note down about the difference between the solid body and what a rigid body is. Now, explain translational motion by given illustration. A rectangular block sliding down an inclined plane without any sidewise movement as shown in figure. Its motion down the plane is such that all the particles of the body are moving together, means they have the same velocity at any instant of time. So here you can see there is an inclination, and on that inclination there is a block that is sliding, that is it is moving from point A to point B. So such motion is called as the translational motion because over here the particles of these block, all these particles will be having the same velocity at any instant of time, and such motion is called as translational motion. So in short we can say the motion of the body in which every particle of the body has the same velocity at any instant of time, such motion is called as the translational motion. So here we can see there is indicated two particles P1 and P2 of this block, and both are moving in the same direction. That means all the particles of the system is moving in the same direction, and both of this particle has the same velocity. Such motion of a rigid body is in pure translational motion. In pure translational motion, at any instant of time, all particles of the body have the same velocity. That means here if we say that this particle P1 and P2 at this instant of time, that is at say t equals to t, then both particles will be having same velocity. If we say if 5 meter per second, then all the particles of this block has the same velocity 5 meter per second. Then such type of motion is called as the translational motion. So students, you may note down this theory. Now let us see what is rotational motion and explain it with example. Here rigid body as a solid metallic or wooden cylinder. This cylinder shifts from the top of the bottom of the inclined plane and thus it has translation motion. All its particles are not moving with same velocity at any instant. The particle near from the axis of the cylinder has less velocity and the particles far away from the axis of cylinder has more velocity. Such type of cylinder velocity is not pure translation, it has combined velocity of rotation with it. So here we can see that there is a cylinder and that cylinder it is rolling down from point A to point B. So here we can see that every time it rolls down the point of contact changes, but it is rotating on its own axis. So these object it has different particles and all of the particles will be having different velocity at any instant of time. Let us consider that at this point, that is at t equals to t, this particle p1, p2, p3 and p4, all these four particles will be having different velocities at t equals to t. All the particles that is near to the axis that will be having less velocity and the particles that is far away from the axis that will be having greater velocity. That means from the axis, if the particle is far away from the axis, then that particles will be having the greater velocity. So velocity increases for the particles that are away from the axis. Near to the axis it will be having less velocity. So all this particle will be having different velocity and such type of motion is called as rotational motion. That means the motion of the object in which the particles has different velocity at any instant, then that motion is called as the rotational motion. The line along which the body is fixed is termed as its axis of rotation. That means we know that suppose we are having a sphere, let us consider the planet, right? It is rotating like this, then these axes, that is the fixed axis, along with it is rotating. So the rotational axis is fixed. Its motion is known as the rotational motion. If all the particles motion of a rigid body move along the circular path and the center of all the circles fall on a definite straight line, then the motion of the body is called as the rotational motion. That means here, suppose we are considering any arbitrary shape object and if it is rotating along its y-axis, then this is called as the rotational axis, and if we suppose choose this particle, then along with the rotation of this body, this particle is also rotating and the path of the motion of this particle has the circular motion. That means the path is circular path and the center of this circle will be the rotational axis. In the same way, if we choose another particle over here, then with rotation this particle also rotates and it makes the circular path. It makes the circular path while rotating. Then this circular path also has its center on the rotational axis. Then such motion is called as the rotational motion. If all particles of a rigid body perform circular motion and the centers of these circles are steady on a definite straight line called as axis of rotation. That means in a rotational motion all the particles will be exhibiting the circular motion and for all of that circular path the center will be on the rotational axis. Example of rotation motion, that is a ceiling fan, a potter's wheel, a giant wheel in fair and merry-go-round. These are some of the examples of the rotational motion. So this is the difference between the translational motion and rotational motion. In translational motion, all the particles of the object will be having the same velocity at any instant of time, and in rotational motion all the particles of the body will be having different velocity at any instant of time. The particle that is near to the axis of rotation will be having less velocity and the particle that is far away from the axis of rotation will be having greater velocity. So this is the main difference between the translational motion and the rotational motion. So students, you may note down this theory. Now let us see the characteristic of rotational motion. In rotation of a rigid body about a fixed axis, every particle of the body moves in a circle which lies in a plane perpendicular to the axis and has its center on the axis. That we have discussed earlier, that if we consider any particle, suppose here the arbitrary shape object, it is moving along the z-axis, its rotational axis is along the z-axis, then all the particles that is rotating, that makes the circular path, and the center of this circle is on the rotational axis, and the plane of this circle, it is perpendicular to that of the rotational axis. In figure, rotational motion of a rigid body shows about the z-axis of frame of reference. Let P1 be a particle of the rigid body, arbitrarily chosen and at a distance r1 from the fixed axis. The particle P1 describes a circle of radius r1 with its center C1 on the fixed axis. The circle lies in a plane perpendicular to the axis. So as you can see over here, particle P1 also rotates along with the body and it makes this circle, and the center of the circle is along the rotational axis, that is on the rotational axis. So P1 is at a distance r1 from the center, so we can consider this distance r1 as the radius of the circle. And another particle P2 of the rigid body, P2 is at distance r2 from the fixed axis. The particle P2 moves in a circle of radius r2 with center C2 on the axis. The circles described by P1 and P2 may lie in different planes. Both these planes are perpendicular to the fixed axis. So here also we consider another particle P2 that is far away from the axis at distance r2 from the center, that is from the fixed axis. It makes the circle and center of the circle is on the fixed axis, that is the rotational axis, and the distance between this rotational axis and the particle, that is distance r2, which is nothing but the radius of this circle. So the circle is also, the plane of this circle is also perpendicular to the rotational axis. But both these circles, circle formed by the particle P1 and circle formed by particle P2, both are in different planes, both are different planes, but both are perpendicular to the rotational axis. For any particle on the axis like P3, R3 is equals to 0, any such particle remains stationary while the body rotates. So if we choose any particle on the rotational axis itself, we can say the distance is 0, because the particle that we are choosing is on the rotational axis itself. So it will be having 0 velocity, that is, it is stationary. So on the rotational axis the particle will be stationary. As we go far away from the rotational axis, the particles will be having greater velocity, its velocity increases. Now in rotation of a spinning top, the axis may not be fixed as shown in the figure, assuming that spinning top rotates at a fixed place. The axis of such a spinning top moves around the vertical through its point of contact with the ground, sweeping out as a cone in the figure. This movement of the axis of the top around the vertical is termed as precession. Here the point of contact of the top with the ground is fixed. So here we can say the spinning of the top, here the rotational axis changes. Initially we consider it is vertical, so rotational axis is along z axis. Then by spinning, it is spinning as well as it is rotating. So rotational axis changes, but this rotational axis is fixed and it comes through the common point of contact, that is the point of contact of the top to this surface, to the ground. That point of contact, from that the rotational axis will be changing, but point of contact remains the same. So this movement is called as the precession. The axis of rotation of the top at any instant passes through the point of contact. So the rotational axis that may be changing, but every rotational axis passes from the point of contact. Another example of this kind of rotation is the oscillating table fan or a pedestal fan. The axis of rotation of such a fan has an oscillating movement in a horizontal plane. That is, this fan that will be moving on a horizontal plane, it is oscillating from one position to another and it comes again to the original position. So it is oscillating about the vertical through the point at which the axis is pivoted. So this is the pivot point which is fixed, and from this fixed point the fan will be rotating. That is, it is oscillating. While the fan rotates and its axis moves sideways, this point is fixed. That is, the point of contact or the pivot point is fixed, but the rotational axis changes sideways. Hence, in case of a top or a pedestal fan, one point and not one line of a rigid body is fixed. Here, only point of contact is fixed, but not the rotational axis. In this case, the axis is not fixed, though it always passes through the fixed point. So, in this case, we can say that whether you consider the spinning of the top or the pedestal fan, the point of contact is fixed, but the rotational axis will be changing, and this rotational axis passes through the point of contact. So, students, you may note down this theory.